okay, in the organisms on Earth, right? Yes, Soumya, good evening. So you can see that the movement of carbon and its compound between the atmosphere and organisms on Earth. This is carbon cycle. It is a gaseous short-term cycle because most of these exchange is done between the atmosphere and Earth, the organisms on Earth. Okay, though carbon can be divided as a short-term cycle and long-term cycle. The short-term that takes place with the atmosphere, and the long-term where the carbon goes into sedimentary cycle as well. Okay, so here we have geological sphere, that is rock, sphere of rock, right? Geological sphere, then biosphere. Biosphere is about living here. Okay, biosphere. So this is the movement of carbon between various spheres of Earth. So you can say simply, okay, you can write the definition. Carbon cycle is the movement of carbon and its compound. Carbon cycle is the movement of carbon and its compounds carbon cycle is the movement of carbon and its compound between various reservoirs of carbon. Between various reservoirs of carbon. Like between Earth and organisms on, between atmosphere and organisms of Earth. So it was between various reservoirs of carbon, and you can write in another sentence like between atmosphere and organisms on Earth. Okay, like between atmosphere and biosphere. Yes, Harsh?
Can you repeat the definition?
From where?
My network or network issue.
Okay, it's okay. So I'm doing it from starting. It is the movement of carbon and its compounds. It is the movement of carbon and its compounds between. It is the movement. Good evening, Sharda. Sharda, is environment going good? I mean, is everything understandable?
Yes, sir.
Okay. Then it is the movement of carbon and its compound between various reservoirs of Earth. Between various reservoirs of Earth, like between atmosphere and the organisms on Earth, which is biosphere. In bracket, you can write biosphere. Surya, good evening, Surya.
Great.
Yes, Surya.
Good evening.
Good evening. Okay. Then let me discuss is what happens. We all know, most of us might be aware of this carbon cycle, that the carbon dioxide present in atmosphere is utilized by the plants, green plants having chlorophyll pigment, right? These chlorophyll pigment in stomatal opening helps in this photosynthesis process, right? And this photosynthesis process absorbs this carbon dioxide and releases food as glucose and this oxygen into atmosphere. Okay. So where this carbon dioxide from atmosphere goes, it goes via photosynthesis into food chain, or you can say into organic chain, link. Okay. So it enters trees, then from the trees or the producers which are eaten by the herbivores, it enters into food chain, and then the respiration, the process of respiration from plants as well as from animals, it gets released into atmosphere. Okay, then the decomposition of these plants and animals leads to entering of carbon into soil. Okay, and with the time this carbon releases as CO2 into atmosphere. When these organic material get decayed, or you can say it get buried deep inside the earth under high temperature and pressure over millions of years, these kind of matter, organic matter, is converted into fossil fuels, right? and this fossil fuels is being utilized by men, and the combustion of fossil fuels again releases a large amount of CO2 into atmosphere, right? So absorption is mainly by the process of photosynthesis, while the release is by respiration, decomposition, combustion, and other anthropogenic activities. Okay. So I think this carbon cycle part is done. And now we are going to discuss the impacts of human on this carbon cycle. Okay. So shall I move ahead now? Here we have impact. I think one of this fact I have discussed earlier. And the fact is that the global carbon dioxide emission, this is actually a data from NASA website, which shows that from 1850s, that is from the Industrial Revolution. Okay, the Industrial Revolution came in 18th or 19th century. Okay, during the 19th century, you can say mid 19th century, especially after that railway and steel factories. So this industrial revolution we had till 1950s, it was fine. Okay, till 1950s it was fine. But then came the exponential rise. Okay, then came the exponential rise. And yes, we mostly determine our emission from the benchmark of 1970s. For present, we determine most of our emissions from the benchmark of 1970s. This year, this decade is taken as reference decade. And then we can see the exponential rise in release of carbon, gigatons of carbon release per year. Okay, which is increasing year by year at very high rate. And yes, this I very much explained I think day before yesterday or on yesterday, that 280 to 3 ppm was the level of CO2 in atmosphere for the past million years. But now it is 407 ppm. The CO2 is 407 ppm because the gigatons of carbon per year release is very high. Which country is the largest generator of this emitter? Which country is the largest emitter or polluter? And what is the rank of India as well? Animesh, China. Okay, what are the other answers? China, okay, India third, okay. Arya, USA. Canada or USA, Disha? So you have to give one answer, Disha, not Canada or USA. Okay, where are other people? Preetham here, Preetham. Ashish Dabral, Joseph, Surya. Give your answer, Surya. Soumya. Aman, you are here as well. Okay, Aman. Animesh, Nareda is saying India is fifth.
I think Bangladesh is first.
Bangladesh, Ashish, no, Bangladesh is not the first one. Okay, so the world's largest emitter now is China. Okay, the world's largest emitter is now China, rank 1. Then the second emitter is US. Okay. Going by the country level, India is third largest emitter, contributing 6%. Okay, India is third largest emitter in the world, contributing around 6% of the total emissions. Okay, while China alone goes for around 50% of the total emission globally. Okay, China, US, India. Yes, Sakshi, you are correct. Then okay, if we go by the third rank is usually given to European Union, but it is a group of 27 countries. Okay, by country, if going by country, India is third, otherwise European Union can come third. No, it is not fifth. It is not fifth, Animesh. It is third. Okay, don't be confused. It is third. India is the third largest emitter of Joseph. Yes, Joseph. Yes, Joseph. Speak yourself.
I'm just reconnecting myself. That's all.
Okay, it's okay. So yes, you can remember that India with 6% of the total emission contribution of total global emission, India is third largest emitter in the world. And the per capita emission is a term where we find how much carbon or amount equivalent, okay, emission equivalent to gigatons of carbon is emitted per person. You can say total emissions divided by population. And yes, we are a very second largest populated country. We have a large population, so the this per capita emission is very low in India. Arpit, please mute your mic. Okay. So after this, I was explaining that. Okay, this part is done. So I was explaining the short-term cycle and this long-term cycle. So the short-term cycle explained, okay, that the gaseous cycle, which was earlier explained, was short-term cycle. While the long-term cycle is a deep Earth cycle. Deep Earth cycle. So you might have heard that Earth has three layers: core, this mantle, this is core, core. Okay, this core, then this is mantle, and this is, here we have crust on the just outer layer. Okay, so it is assumed that in mantle we have almost 1,000 times more carbon present than on the crust. But we have very little awareness because the depth is around 3,000 kilometers of mantle, and for core it is 6,400 kilometers, equivalent to radius of Earth. So very little is known about the presence of carbon and its movement in deep inside the Earth. But whatever information we have gained is from this emissions from volcanic eruption. Good evening, Chumpi. I think you were late. Then emissions. Okay, try to be on time. Okay. Please mute your mic, Chumpi. Then this volcanic eruption, right? Volcanic eruption. It becomes one of our sources of knowing about inside of Earth. So the large amount of CO2, emitted, from this volcanic eruption indicates that there is a large deposit of carbon in some form deep inside the Earth. Okay, and how the circulation, how the cycle goes on? The cycle goes on like this, that as I told you that this carbon gets deposited at sediments or organic matter. Okay, the carbon forms the part of carbon is the base of organic matter. Okay, without carbon, life is not possible. Okay, so this presence of carbon, this sediments and organic matter get deposited deep inside the Earth. And this carbon deposit, these deposits of carbon, what they tend to convert into, either they convert into rocks, like we have igneous, metamorphic, or other type of rocks. Okay, igneous, metamorphic, and sedimentary rock. So either they convert into rocks or they convert into fossil fuels. In rock form, they are usually found as carbonates. Okay, like calcium carbonate. You might have heard calcium carbonate. Okay, marble. So marble is a form of deposition of carbon. Then other one is fossil fuel, where organic matter under high temperature and pressure get deposited deep inside the Earth, which when exposed is utilized as fuel by humans. Okay, or by drilling or mining activities, right? Either it gets self-exposed or we drill it, mine it, okay, and use as. And I've earlier told that this increase in amount of CO2, the impacts what it is leading to. Okay, we all know that this is because of industries. The increase in CO2 is because of industries. Okay, because of increasing population, that's rate of respiration increases. Then waste production is increasing, so also this amount of CO2 is released is increasing. Okay. So you can write in impacts of human these points: larger scale waste generation, okay, large scale waste generation, then larger emissions, deforestation is also leading to this carbon increase because the carbon stored in forest is released. Okay, then what was the other point? Anyone? Large scale waste generation, larger emission, deforestation. You can write about combustion, especially in vehicles and factories. Okay. Are we good till here? It seems that many of you are sleeping. Is it so?
No, sir.
Satyam says yes, sir. Satyam, are you sleeping? Soumya is also saying yes, sir. Okay, you were answering for the earlier question. Okay. So this part is okay. Okay, the impact of humans. Then what it results into, or what are the consequences of this increasing CO2 level? We have already discussed about that: global warming, sea level rise, okay, melting of glaciers, right? We have already discussed a bit of these things, right? Okay or not? I'm not getting the answers. Okay. Then one more thing, I am moving towards the solution in this part as well. What solutions we have took to. So there are several solutions we have moved towards, which is this carbon sequestration. So what is this carbon sequestration? Please write this term, carbon sequestration. Okay, and I'll define this as well. You can write this carbon sequestration. Okay, not this CO2. This is carbon sequestration. Because the amount of CO2 has been increased in atmosphere as well as in oceans as well, to such an extent that we witness now ocean acidification process, right? This amount of increase in CO2, which in the presence of hydrox, this H positive ion, get converted into carbonic acid. Okay, carbonic acid, which is a soft acid. Okay, and this has led to increase in acidification, oceanic acidification. And this oceanic acidification is causing habitat disturbances.
Sir, please repeat the
Which
amount from starting carbon sequestration.
I'm not defining it here. I'm just telling you about the oceanic acidification.
Okay.
Okay, when I'll define, I'll dictate it. Don't worry. Just first get the concept. Okay. What I was saying is that the amount of carbon dioxide has significantly increased, both in atmosphere, from which we have repercussions like that, the global warming, sea level rise, and when also in this oceanic part, right? And this oceanic carbon dioxide in the presence of water, okay, water, H2O, which gives this H positive ion. It's a part of chemistry, right? But a bit of chemistry is okay. So this H positive ions, when gets with CO2, when mixes with CO2, it forms a compound called carbonic acid, and this carbonic acid is leading to oceanic acidification. Oceanic acidification, and this oceanic acidification is causing habitat destruction for aquatic animals. It is also harming. You might have heard about mollusks. Any one of you heard about these mollusks? Then there are animals like, I don't exactly remember the name. They have this calcium carbonate or lime. as their outer covering. I think mollusks are those animals who have calcium carbonate covering on their outer layers. Okay. So this calcium carbonate covering gets dissolved in the presence of acid. Okay. And this carbonate covering gets dissolved in the presence of this carbonic acid or in acidic environment, which leads to death of these organisms. Okay, and increasing the death and decay matter in oceans or on oceanic beds. Okay, and this is one of the reasons why the corals are dying. Okay, this is also one of the reasons, this oceanic acidification, because corals are highly sensitive, right? So this oceanic acidification is also one of the reasons why corals are dying. And this is because of rise in carbon dioxide. So we were seeing that what are the consequences of rise in carbon. So what the solution that was proposed was sequestration of carbon. So you can write the definition of this carbon sequestration. The definition is very simple. It is the long-term removal of carbon. It is the long-term removal of carbon from the atmosphere. Okay. Carbon sequestration is the long-term removal of carbon from the atmosphere, right? Okay. Please answer. Okay, then yes, Ash. Okay. So this is carbon sequestration. In this, what we do, we apply various methodologies. Various methodologies have been found in which we can capture. Okay, you can say long-term removal, capture of carbon from atmosphere. Okay, so in this method, we capture carbon into certain. You can say carbon is contained in a somewhere. Okay, from where it is hard to get released. So it is extracted from the atmosphere and captured at some place, right? So the methodologies we are using for this carbon sequestration, you can say the natural methods of sequestering carbon in oceans, soil, forest. Then there are artificial methods like use of aerosols. Okay. Then there is method of carbon sequestration in this shale gas. Okay, shale, or you can say there are mines. Actually, in extraction of this shale gas from the mines deep inside the earth, what we do, we insert. Suppose this is a mine, and we have a certain opening here and an opening here. So what we do, we with high pressure, we enter this amount of CO2 into these you can say openings. Okay, from this opening, this space is filled with high pressure carbon dioxide, and this leads to movement, outward movement of the shale gas. So the shale gas is used as fuel, and this carbon gas gets sequestered in this space, right? So you can say carbon dioxide sequestration in mines or in captive spaces. Then what in aerosols? In aerosols, actually amount of some aerosol particle. Aerosol is you can say very small particles which can improve the reflection of light back to space, so that the amount of rays entering the earth and actually trapped gets reduced, which reduces the global warming. Okay, so it is an indirect method of reducing the global warming. Then carbon sequestration, I think, okay, we have done. Actually, there are several other methods as well, like formation of iron compounds, iron carbon compounds, and this was tried in Ireland. This method was tried in Ireland. Okay, these compounds, how will aerosols be used? Okay, Animesh, I told you that aerosols is an indirect method of reducing global warming, not specifically for the carbon sequestration, right? They are one of the methods of solving that global warming issue. So there is another method of this iron carbon compounds are made. Okay, this iron carbon compounds are made, and in this method, these compounds, I think several name was given to them, and it was tested in several rocks of Ireland. It was tested method where India was also involved, and these compounds are then buried deep inside the earth. So these are the methods of carbon sequestration. There are also several methods like sequestration in space, which is yet under consideration. Then there is one more method which I was to discuss. Okay, I'm not remembering it. It's simple. Okay, nothing to be worried, because they are you can say they are eccentric things, just for the sake of information. Only thing that you must know about this one. Okay, this one is important. That I told you in that INDC part that we are trying to create 2.5 to 3 billion tons of carbon sink, so that carbon can be sequestered into our forest. Okay, so carbon sink creation naturally, or carbon can be sequestered into by artificial manner as well. Right? Okay, clear up to here. Okay. Then now I'm moving towards the next cycle. The next cycle is this night. Okay, this question is here, and you have to answer this question. The question reads: which one of the following adds or add carbon dioxide to the carbon cycle on planet Earth? Okay, this is a UPSC question. I think from 2013, year 2013 or 14. Okay, so you have to answer this question: volcanic action, respiration, photosynthesis, decay of organic matter. Which of the following? Okay, which of the following adds CO2 to atmosphere? Well, your answer is 1, 3, 4. So you say that respiration do not add CO2, right? Then Animesh C.
By mistake, sir. Sorry.
I got it. It was okay. I got it. You were to write 1, 2, 4. Okay.
Yes, sir.
Then Aman, Satyam, Lakshmi, Prasanna, Pooja, Sakshi. Okay, I think every one of you know it. Okay, don't worry. So the answer is C. Yes, that the volcanic action, the eruption of volcanoes add amount of carbon dioxide. Then respiration as well adds the amount of carbon dioxide. Then photosynthesis, it is actually removal of carbon dioxide from the atmosphere by plants, right? Then dead and decay organic matter, it also adds CO2 or carbon, because carbon is the basic content of organic matter, which on decay of this organic matter leads to soil. Okay. Okay, now the next cycle, the next topic is this nitrogen cycle. So here the diagram of nitrogen cycle, though it is not very much clear, let me explain it here first. What happens, this cycle is completed in 5 stages, right? This is it is actually the same, though every cycle is same. It is a movement of that compound or circulation of that compound between terrestrial, atmospheric, marine, ecosystem, biological processes or physical processes. Okay, so you can say that the movement between biosphere, atmosphere, hydrosphere and lithosphere. Every cycle, the same pattern is there of movement, but yes, it can be slow, it can be fast, it can be long term, short term. Okay, the main thing is in what form it is mainly going into this cycle. Okay, so this nitrogen cycle is in this 5 parts, and what happens, this atmospheric nitrogen is first enters into earth. So the first part is fixation of nitrogen. I'll come to those parts, don't worry. Okay, so a bit of information for nitrogen. It forms around 78 to 79% of the air and is the basic constituent of amino acids, okay, which form the protein. So all that DNA, RNA, okay, they are formed from this nitrogen base. Clear? So nitrogen is very important. Again, nitrogen is also very important for support of life. Okay. And it is 79% by volume in here. Okay. Then coming to this cycle. So what happens? The first, this atmospheric nitrogen is converted into or fixed to the nitrogen on Earth. Okay. And this fixation takes place by conversion of this nitrogen into ammonium compounds or ammonium ions. Okay. You can say conversion into ammonia. Okay. And how this conversion takes place? This conversion takes place by three methods. One can be natural, by nature. So by nature means it is by the climatic processes like this lightning. Okay, somewhat amount of lightning leads to conversion of nitrogen into ammonia, which is absorbed by soil, right? Then another one is by men. What we do, we convert the nitrogen or the into a gas, nitrogen oxides, into ammonia by our industrial processes, by conversion into chemical fertilizer, so that they can be easily absorbed. Yes, Soumya? Soumya?
Sorry, sir. It was actually reconnection due to network issues.
Okay. Okay. Then conversion by men by our industrial processes and chemical fertilizers. And the last one is it is from microorganisms. Microorganisms. There are several microorganisms which converts this nitrogen into seems not working. Okay, microorganisms, right? They convert this nitrogen of atmosphere into this ammonia. Okay. Then what happens? This ammonia gets converted into this. This enters from the soil after it is converted into ammonia. Then the nitrification occurs, where it is converted into nitrites or nitrates, then absorbed by plants, then to the food chain, then decomposition leads to further addition to soil and back to environment. Then decomposes release again into ammonium ion, and there are denitrifying bacteria. Denitrification leads to again formation of N2O, again release to atmosphere. So now I will come to each process one by one. Okay, don't worry. So this is essential processes involved in nitrogen cycle, right? So the first process I was discussing is nitrogen fixation, right? This nitrogen fixation. So I told you that it is done by human, by their industrial processes, then by nature, by some extent by lightning, and then by microorganisms. Microorganism can be of two types. One is those living in plants, or you can say symbiotic relationship with plants. For example, rhizobium. Okay, rhizobium is a kind of bacteria which is living in root nodules of leguminous plants. What are leguminous plants? I think speed of sound is quite slow, huh? It's taking a long time to reach to you people. Is there time lapse? अभी तक सुनाई नहीं दिया क्या? मतलब I mean, I asked some for answers. What are the leguminous plants? Aman, if there is no time lapse, why you people are not answering? No one is answering. It seems that you people are sleeping. I am speaking on this side, and you are have forgotten Animesh. Okay. No one is from biology background, geology or biology or botany. Anyone? Or agriculture background? Yes, Palak. Palak, what's your background?
Biochemistry.
Biochemistry, then you must know, I think. Okay,
So they are the
Paul.
plants which belong to Fabaceae family and they're able to fix atmospheric nitrogen.
Yes, correct, you are right. Kirti, do you want to speak something? Kirti. Shada. Shada, are you there? Chumpi.
Yes, sir, I'm here.
You are here, but your answers are not here. Please come with your answers.
Sir,
You can
I
write
really,
in. Okay,
I really
write in
don't
message.
understand.
Okay, you don't know. Okay, please write in message whether you know or don't know. Please write in message. Okay, soil enriching plant Arpit. Okay. So legumes are basically nitrogen fixing plants. Okay, legumes are basically nitrogen fixing plant. Okay, so what happens? These legume plants, they have several symbiotic relation with a bacteria called rhizobium. And these rhizobium, they take their food from plant and help in fixing that nitrogen from air, okay, into nitrogen. And you might have heard about this NPK. What is this NPK? Anyone? What is this NPK? Yes, Adya. Example is pulses. Very good. Soumya. I think NPK is not that tough. Yes. Fertilizer. Yes. Soumya. Nitrogen, phosphorus, and potassium. You are absolutely correct. So they are the macronutrients. Okay. Soil needs macronutrients in large quantities. And they are the important fertilizers provided by, you can say mostly of fertilizers are provided by government. So I am saying here that NPKs are the fertilizers provided by government on subsidized rates. Okay. Under that national fertilizer subsidy scheme. Okay. So okay, it is actually nutrient subsidy scheme. So this NPK, in this nitrogen, the main source of nitrogen is from urea, right? These farmers are using urea. So why they are using this urea or this nitrogen? So as to fulfill or to compensate the deficiency of nitrogen in soil. Okay. Because mostly what we are growing wheat, rice. Okay. Wheat, rice. These are the plants which are mostly grown in as agricultural crops in India. Okay. They almost make up 60 to 70% of our total production. Okay, so what happens? Most of the nutrients taken by these plants, suppose they take nitrogen. So what this will lead to? This will lead to deficiency of nitrogen in soil. Okay, so we need to either we can naturally fix it by growing this legumes. Okay, example is pulses. That's why the government focuses on growing of pulses, so that nitrogen deficiency can be naturally fixed, or we can artificially fix it by using urea. Okay, but what happens in artificial methods? Farmers overdo it, and this overdoing of addition of nitrogen leads to soil degradation. Okay, leads to soil degradation. The whole thing is that legumes are nitrogen fixing crops with the help of rhizobium bacteria, and they fix the nitrogen deficiency in soil. Example is pulses. Okay, example is pulses. So this I was telling that there are two kind of plants, or two kind of microorganisms. The one is living in symbiotic relationship in the root nodules of plant, and the other is free living bacteria. And the free living bacteria are nostoc and azotobacter. So in this nitrogen cycle, it is very important to remember the names of these bacteria. All: rhizobium, nostoc, azotobacter, nitrosomonas, nitrococcus, and then there are several algae as well, like cyanobacteria. Okay, blue-green algae. And it is important because they are asked. Okay. They may ask you that how many of these are nitrifying bacteria and how many of these are denitrifying bacteria. Mostly in prelims, okay, mostly in prelims. Okay, so yes, you must know that what are the functions of these bacteria or the algae. Yes, algae and bacteria both do these kind of conversions, right? So the first three parts of that fixing nitrogen by humans, nature, and microorganism is done. They are of two kinds: the free living and the rhizobium living in root nodules, right? Then second process. Now we are moving to second process of, I think you could have written that nitrogen fixation part. Or should I dictate? Okay, write a heading that there are 5 processes involved in nitrogen cycle. Have I dictated the definition of this nitrogen cycle? I think the time lapse is very large. Okay, so write a heading of this nitrogen cycle, and now I'm going to dictate the definition of nitrogen cycle. Okay, so the definition is that the nitrogen cycle is the circulation of nitrogen. Nitrogen cycle is the circulation of nitrogen and its converted compounds between atmosphere, biosphere, hydrosphere, and lithosphere. It is the circulation of nitrogen and its converted compounds between atmosphere, biosphere, lithosphere, and hydrosphere. Okay. Through various physical and biological processes. Through various physical and biological processes. Through various physical and biological processes. And after this, you can write that this nitrogen cycle involves 5 components or 5 processes. This nitrogen cycle involves 5 processes, right? Please do it fast because I have to complete this lecture by tomorrow. And still we have 9 to 10 slides in this. Okay. So the first topic we discussed, the first process we discussed is nitrogen fixation. And in this nitrogen fixation, the conversion of, simply write a one-line definition. Here, conversion of atmospheric nitrogen into ammonia takes place. Okay. Here, conversion of atmospheric nitrogen gas into ammonia takes place. Okay, as this ammonia can be easily utilized by plants. Then you can write it, this fixation is done in 3 manners: humans, this natural, and by microorganism. In the microorganism, you can make sub points like by free living bacteria and by this root nodule bacteria called rhizobium, root nodule bacteria. And here also you can mention the nostoc and azotobacter. Okay, done for this nitrogen fixation part, or should I repeat something? Shada, are you writing? Manju, done? Manju? So should I repeat something, Manju? Arpit, done Arpit? Surya. Surya, are you writing? Okay, Surya, done. Kirti, done. Okay, now I am moving to the next definition of nitrification. And in this process of nitrification, what happens? It is simply conversion of this. And the first point was conversion of atmospheric nitrogen to ammonia. Now this ammonia is converted into nitrates or into nitrites. Okay, the conversion into nitrates is done by this nitrosomonas bacteria, right? And into nitrites is done by this nitrococcus bacteria. Okay, these nitrates and nitrites are directly absorbed by plants. So in write a heading nitrification and write simply the conversion of ammonia into nitrates and nitrites. The conversion of ammonia into nitrates and nitrites by nitrosomonas and nitrococcus bacteria respectively. By nitrosomonas and nitrococcus bacteria respectively. Okay, and this these nitrates and nitrites, actually this is the form of fertilizer we make. Okay, this nitrates and nitrites is the form of fertilizer we make, and they are easily absorbed by the plants for synthesis of proteins. Okay, because nitrogen forms the base for amino acids, and these amino acids are the basic unit of these proteins, right? Okay, then now on the assimilation part, so this already fixed nitrogen in this assimilation क्या है? मतलब लेना, ठीक है? Assimilation is to collect. Okay, to collect only. So this assimilation part is, you can say, the collection of already fixed nitrogen by plants. So the nitrogen which has already been fixed into soil is just collected by the plants for its metabolic activities and turned into organic molecules like proteins of DNA and RNA. Okay, these proteins later move to food chain. Okay, so here in assimilation you can simply write the conversion of already fixed nitrogen into organic molecules. Conversion of already fixed nitrogen into organic molecules like proteins by plants. Conversion of already fixed nitrogen into organic molecules like proteins by plants. Okay. So what happened till now? The first part is conversion into ammonia, then conversion into nitrates and nitrites, then assimilation of these converted products. Then after assimilation, what happened? Now it has moved to food chain. So what will happen now? Now what will happen, that there will be generation of waste by the plants and animal, decomposition of the decayed matter, and this decomposition and waste generation will lead to release of these nitrogen compounds, okay, in the form of inorganic ammonia. So you can say it is some form of nitrogen compound which is converted back to inorganic ammonia in the process called ammonification by ammonifying bacteria. It is not very much important. Okay. Okay, clear? Then you can write in this ammonification. Ammonification is the conversion of living waste and decayed matter. Ammonification is the conversion of living waste and decayed matter back into inorganic ammonia. Back into inorganic ammonia. Okay, back into inorganic ammonia. In bracket, you can write by ammonifying bacteria. Back into inorganic ammonia. The last point is denitrification. Denitrification. Okay. Now it is similar. First we converted into ammonia, then into nitrates. So it is just similar. These waste compound having nitrates has been converted to ammonia, and now ammonia would be converted back to gaseous nitrogen to be released into atmosphere. So what the denitrifying bacteria? There are denitrifying bacteria which aids this process. No need to remember the example, Animesh, because lot of names would be there then. Okay. So simply just remember what is denitrification. It is conversion of nitrates back into gaseous nitrogen. Okay. Conversion, right, in denitrification process, conversion of nitrates back into gaseous nitrogen. Conversion of nitrates back into gaseous nitrogen is called denitrification. Now I've completed all the 5 processes. Now you can ask anything. Anything on the page. Anything. Or done. Or you can say done. Okay, then I think I should move ahead. Sir, the examples of first 2 processes. Yes, the names I have given are the important ones, and the rest which I have not given, because you should not come across so many names. Okay, so just remember these names only. Surya, Sharda, Satyam said done, sir. Then who is left? Manju. Manju said done. Okay, then Lakshmi. Okay, then I'm moving towards the next slide, which is this. Okay, this is a question. Okay, answer this question. Acid rain is caused by the pollution of environment by. So which of the components cause this acid rain? Give me the answer. Okay. Shada, why don't you answer? Shada, don't worry about the result. Okay, don't worry about the result. The only thing that you must be active, you must be doing something. Okay, with time you will learn whether you are right or wrong. Okay, today is the learning phase. Being right or wrong doesn't matter. Today we are learning, so being right or wrong doesn't matter. Okay, so please give answers whether correct or not. Okay, so the answer, yes, it is D, as everyone of you know. Okay, so it is nitrous oxide and sulfur dioxide. The compounds of these are called NOx and these are called SOx. Okay, the oxides of sulfur and the oxides of nitrogen, and they are released by those fossil fuels. Mostly their release in environment is because of combustion of fossil fuels. And some of you might know about that BS6. What is this BS6? And what the content of this as sulfur has been reduced up to? Does anyone have read about this BS6? I think people in Delhi must know it. Manju, no. It's shocking that you people don't know. Emission standard, I think yes, Parag, they are the emission standards. Bharat Standard 6 based on Euro norms. Okay, actually in 2000 or you can say in the last century, in the late last century, Animesh, what is there to repeat? What should I repeat, Animesh? I missed the last few minutes. Nothing. It was only about question, and we were asking that what is this BS6? We said that the fossil fuel combustion leads to this NOx and SOx formation, the oxides of nitrogen and sulfur, and we were just asking that what is this BS6? Okay, Animesh. So Euro norms were made in US. Okay, Euro norms were made in US. And these norms were aimed at reducing the air pollution, okay, from the internal combustion engine vehicles. Those who have read about this, okay, don't worry. These are vehicular emissions, emission from vehicles, which significantly increased in Europe, led to the condition of formation of those smog conditions, okay. So the European countries, when they decided to move towards better environment to reduce the pollution caused by air, okay, to reduce the pollution caused by air, the European Union came with this Euro norms, and in this they significantly reduced the amount of various gases emitted, okay, like this nitrogen oxides, sulfur oxides. Okay, CO, carbon monoxide, then CO2 is little less controllable than methane, emission of methane. Okay, there are other gases as well, and they are very well part of this National Air Quality Index. Okay, there is NACS program in which we have, I think, eight gases like PM 2.5, PM 10, particulate matter. Okay. So what happened? These Euro norms were formed specifically for the diesel engines to reduce the emissions of pollutants into the air or atmosphere. Okay. So India, you can say India also accepted these Euro norms in the name of BS, Bharat Standard Norms. Okay. And we were having this BS norms, I think, in April 2020. Okay, in this April 2020, on 1st April 2020, as per the guidelines of Supreme Court. Earlier we were having that BS4, which came in 2018, I think 2017 or 18. Okay, so on 1st April 2018, this was also on the direction of Supreme Court. Okay, so what happened on the first day? It was pre-decided that India would skip the BS5 norms altogether, and we would directly move from BS4 to BS6 norms, right? BS4 to BS6 norm to improve on emission standards. So on 1st April, as per the direction of Supreme Court, India accepted BS6 norms in its entirety. Okay, complete for all the new purchase of new vehicle. Every new vehicle purchase should be on BS6 norms, right? And in many of the cases, like in buses, in public transportation, BS4 was the baseline. That is, those vehicles having less than BS4 standards were to be discarded. Like BS3, etc. were discarded. And in public transportation, we have BS4 norms, while for the purchase of new personal vehicle should be on this BS6 norm. So this BS6, it is to reduce sulfur by 90%. The content of sulfur as compared to BS4 would be reduced by 90%. Okay, and similarly there will be reduction of a certain amount of nitrogen as well. The oxides of nitrogen would also be reduced to a great amount. Okay, so this is your homework. Tomorrow you would have to read this BS6 norms because many of you don't know it. So the first person to describe this tomorrow would be Sada. Okay, Sada. Am I clear, Shada? You will first describe this BS6 norm tomorrow. And I'll ask everyone. Okay. So for now, I'm leaving this BS6 here. And I think it's 5 now. So we should end our class now. So thank you for the day. And okay. So is it clear? All clear? Okay, Aman. Thank you. So you have to come with this BS6 norms, right? Tomorrow. Okay. Then if it is clear, then thank you. Have a nice day.